Alright, Chapter 5, Wire Rope. Non-Resident Training Course, Steelworker, Volume 2, NAVEDTRA14251. Distribution Statement, approved for public release, distribution unlimited. Chapter 5, Wire Rope. Wire rope is stronger and lasts longer and is much resistant to abrasion than a fiber line. Because of these facts with the wire rope is due to the hoisting tasks that are too heavy for the fiber line to handle. Also, many movable components of the hoisting device attachments are removed by wire rope. Wire rope is an intricate device made up of a number of precise moving the parts. Wire rope is designed and manufactured to maintain a definite relationship with one another. This relationship of the wire rope has a flexibility strength crucial to the professional safe hoisting operation. Wire rope. The characteristics discussed with the construction of the characteristic specification and the criteria used for the selection of wire rope related attachments and proper handling procedure for the wire rope are all discussed. Note, in the Navy you may hear of the wire rope referred to as wire or rope, but never as line. Wire rope construction. Wire rope is composed of 3 parts: wire, strands, and core. A predetermined number of wires of same and different size are fabricated in a uniform arrangement with a definite laid to form a strand. The required number of strands then is then laid together symmetrically around the core to form a wire rope. Wires. The basic component of wire rope is the wire made from steel, iron, or other material in various sizes. The number of wires to a strand vary. Figure fabrication wire. Wire, strand, core, wire rope. Cross-section core, strands, and wires. Depending on what the purpose of the wire rope is intended, the wire rope is designated with the number of strands per rope and the number of wires per strand. Thus, 1/2 inch by 6 by 19 wire rope has the strands with the 19 wire per strand, has the same outside diameter, 1/2 inch. 6 by 37 wire rope has 6 strands with 37 wires. A smaller strand per strand. Strands. The design arrangement of the strand is called the construction. Wire to strand may all be the same size with a mixture of size with the most common in strand construction: ordinary, scale, and Warrington and filler. Ordinary constructions are all the same size. Scales with large diameter wires used on the outside of the strand with a resist abrasion. Smaller wires inside to provide flexibility. Warrington is where alternate wires are large, small to combine great flexibility resistance to the abrasion. Filler is where small wires fill the valleys between outer and inner rows of the wires to provide good abrasion and fatigue resistance. Core. The wire that core supports strands laid around it. These 3 types of wire rope cores are fiber wire, strands, independent wire rope. Fiber core may be hard fiber such as manila, hemp, plastic, paper, steel. The fiber core offers for the advantage of the increased flexibility. It also serves as a cushion to reduce effects of sudden strain. Acts as oil reserve lubricating wire strand to the reduced friction. Wire rope with a fiber core issues with flexibility of the rope is important. Figure 5.3 shows the core structure: fiber, wire, strand, independent wire rope. Wire strand resists more than a fiber core and also resists more heat than a fiber core. Also adds 15% of the strength to the rope. However, the wire strand core makes the wire rope flexibility than a core, less flexible than a fiber core. Independent wire rope core is separate wire rope over the main strands of the rope as are laid. The core strengthens the rope, provides supports against the crushing and supplying maximum resistance to heat. When inspection discloses unsatisfactory conditions to a line, ensure the line is destroyed, cut into small pieces as soon as possible. Precaution prevents the defect of the line from being used for hoisting. Wire rope manufactured by either 2 of the method strands of the wire shaped to the form of the curvature furnished rope before laying up rope is determined to form wire rope. Figure 5.2 shows the common strand constructions: 6 by 10, 8 by 10, 6 by 10. You have fiber core, seal, NWRC, seal, paracore, Warrington fiber core, filler fiber core, and filler WRC. When they are not shaped to the fabrication of the wire rope is termed non-preformed wire rope. The most common type of the manufactured wire rope is preformed. When the wire rope is cut, it tends not to unlay and is more flexible than non-preformed wire rope. Non-preformed wire rope in twisting procedure for the stretches in wire. Therefore, when it is cut or broken, stress causes strands to unlay. Warning: when the wire rope is cut or broken, the almost instantaneously unlaying of the wires and strands of non-performed wire rope can cause serious injury to someone that is careless or not familiar with the characteristics of the rope. Grade of the wire rope. 3 preliminary grades of the wire rope are mild plow steel, and improved plow steel. Mild plow steel wire rope. Mild plow steel wire rope pliable that can stand repeated strain, stress, its tensile strength, resistant length of wide strands to form 200,000 to 220,000 pounds per square inch. Characteristics make it desirable to cable tool, drilling, other purposes with abrasion encountered. Plow steel wire rope. Plow steel wire rope is unusually tough and strong, but the steel has a tensile strength of 220,000 to 240,000 pounds. Plow steel wire rope is suitable for the hauling, hoisting, and logging. Improved plow steel wire rope. Improved plow steel wire rope is one of the best grades of the rope available, the most common rope used with the Navy construction force. Improved plow steel, stronger and tougher, more resistant to wear than either mild plow steel or plow steel. Each square inch of improved plow steel can strain from 240,000 to 260,000 pounds. Therefore, the wire rope is especially useful for the heavy-duty service, such as cranes with excavating and weight handling attachments. Lays of the wire rope. The term lay refers to the direction of the twist of the wire or strand. The direction of the strands are laid in the rope. In some instances, both the wires and strands of the rope laid in the same direction. In any other instances, the wires are laid in one direction, strands are laid in the opposite direction, depending on the intent of the use of the rope. Most manufacturers specify the types of lay of the wire rope to be used on their pieces of equipment to be sure that they consult with the operator's manual with the proper application. 5 types of lays used with the wire rope are as follows: the right regular lay, a right regular lay rope, as the wire strands are laid to the left, while the strands and are laid to the right to form a wire rope. Left regular lay rope. The wire strands are laid to the right, while the strands are laid to the left to form a wire rope. In this lay, each step fabrication is especially opposite from the right regular lay. Right lang lay low. Right lang lay. A right lang lay rope is the wire strands and the strands in the rope are laid in the same direction. For instance, the lay is to the right. Left lang lay rope. Wire strands and the strands in the rope are also laid in the same direction. In instance, the left laid is to the left rather than the right, as in right wrangler rope. Reverse lay. The reverse lay rope, the wires of one strand are laid to the right, while the wires of nearby strands are laid to the left. The wires of the next strand are laid to the right, and so forth, but in alternate directions from one strand to the other. Then all strands are laid to the right. The 5 different lays of wire rope are shown in Figure 5.4. Lay length of the wire rope. Length of the wire rope lay is distance of the measured pair, while center line wire rope and strands make one complete spiral turn around. When the rope length of the strand lay and the distance measured parallel to the center line of the strands in one wire makes one complete spiral and turn around. The strand lay length measurements is shown in. So Figure 5.4 shows the lays of wire rope. You have the right regular lay, left regular lay, right lang lay, left lang lay, and reverse lang lay. Classification wire rope. The primary types of the wire rope of the Navy construction force consists of 6, 7, 12, 19, 24, 37 wires. Each strand, usually wire rope, has 6 strands laid around the core. The 2 most common types of the wire rope are 6x19 and 6x37, shown in Figure 5.6. 6x19 has 6 strands of 19 wires at each strand, and the stiffest and strongest construction of the type of the wire rope suitable to general hoisting operation. 6x37 wire rope has 6 strands of 37 wires in each strand. It is flexible, makes it suitable for cranes and similar equipment where sheaves are smaller than usual. The wire in the 1637 is smaller than the wires in 619 wire rope, consequently not standing the abrasive wear. Figure 5.5 shows the lay of the length of the wire rope. The strand number 1 through 6, 1 rope lay. Figure 5.6b shows 619 wire rope and 637 wire rope. Wire rope selection. Several factors must consider when you select wire rope for the use of the particular type of the operation. Manufactured wire rope that can be withstand all the different type of the wire strength is projected and possible because of the factors. Selecting rope is often a matter that you must sacrifice one quality to have some of the other urgently needed characteristics. Tensile strength of the strength necessary to withstand certain maximum load applied by the rope includes verse strength measured in so-called factor safety, crushing strength of the strength necessary to resist compressive squeezing force of the distort cross-section of the wire rope as it runs over sheaths, rollers, hoist drums under a heavy load. Regular lay rope distorts less than the situations than lang lay. Fatigue resistance. Fatigue resistance ability to withstand constant bending, flexing of the wire rope that runs constantly with a sheath and hoist drums. Fatigue resistance is important, with the wire rope must be at high speed. The constant rapid bending of the rope can be reckoned individual wires in the strands. Lay rope are the best for service requiring higher fatigue resistance. Ropes with smaller wires around outside of the strands also have greater fatigue resistance since they have strands that are more flexible. Abrasion resistant. Abrasion resistance ability with a strand with a gradual wearing away of the outer metal of the rope that runs across the sheath of the hoist drum. The rate of abrasion depends mainly on the load carried by the rope and the running speed. Generally, abrasion resistance of the rope depends on the type of the metal made of the side of the individual core outer wires of the wire rope made of the harder steel as the improved plow steel has considerable resistance. Abrasion ropes, larger wire formation outside the strands, more resistant to wear. Ropes having smaller wires than weigh away more quickly. Alright, corrosion resistant. Corrosion resistant stability with a chain of the dissolution wire metal with the result of the chemical attack of the moisture atmosphere elsewhere with the working environment. Rope that are of the poor put to static work such as guide wires may be protected. Corrosive elements paint with the other special dressing. Wire rope must be galvanized. Corrosion protection. Most wires used in the crane operation must rely on the lubricating dressing. Double as corrosion preventive. Measuring wire rope. Wire rope is designated with the diameter an inch of the correct method of measuring. Wire rope is the measure of the tops one strand on the two of the top of the strand directly opposite to it. The wrong way is to measure across the two strands side by side. To ensure the accurate measure of the diameter wire rope, always measure the rope at 3 places at least 5 feet apart. Usually the average of 3 mentions of the diameter of the rope, as no a crescent wrench can be used as an expedient means of the measuring wire rope. Wire rope safe working load. Safe working load for the wire rope is defined with the load that can be applied with the valve of the rope to provide efficient service and also prolong the life of the rope. The formula computing the safe working load over the wire rope diameter rope squared multiplied by 8. This is what we have the diameter of the rope squared times 8 times standard working safe working load in tons. Example: the wire rope 1/2 inch diameter computes safe working load for the rope. First step, convert 1/2 the decimal number of the dividing the bottom of the number of the fraction, top number of the fraction 1 divided by 2 with equal to half. Now next compute the same working load, safe working load by half times 8. State working load of 1/2 inch rope is 2 tons. 5/7 of the correct aid in correcting method measuring wire rope. Incorrect. Caution, don't downgrade the safe working load with the wire rope because of the old, worn, poor condition wire rope. These conditions should be cut up with the discard wire rope failure. Some of the most common types of wire rope failure following use the incorrect construction grade, dragging over the obstacles, improper lubrication, operating over sheath of the drums of the inadequate size, overriding cross winding in the drum, the operating over sheath of the drains with the improperly fitted with the groove broken flange, jumping off sheath with exposure to acid, fumes, and it shows wire rope clips. Show the U-bolt saddle and the thimble. Correct. Incorrect. Alright, use an improperly attached fitting grip with it may be applied with the penetrate between the strands caused with the internal wear being subject to the serve of the continuing overload wire rope attachments. Attachments can put on the wire rope to allow it to attach to the other rope, for example, the pad eye of the chain with the equipment. End fittings, some end fittings are easily equipment chain with the wire rope clamps, thimbles with the wedge socket, the basket, soft, generally these attachments permit the wire rope to be used, greater flexibility, and a more permanent splice for the allow the attachments to allow the same wire rope to be made with the numbers of different agreements. Arrangements, wire rope clips. Wire rope clips are used to make eyes. The wire rope is shown in figure 5.8. The U-shaped part of the clip, the thread ends called the U-bolt on the other. Part is called the shell with the L stands with the diameter wire rope with the clip with they always play for the clip with the U-bolt bitter dead in but not on the standing part of the wire rope. When the clip ends and attached incorrectly, starting part of the live end of the wire will be over the smash and splash. Rule of thumb: remember, attaching a wire rope clip, never saddle a dead horse. 2 simple formulas for figuring number of the wire rope clips needed as follows: 3 times the wire rope diameter plus 1 number of clips. 6 times the wire rope diameter space between the clippings. Another type of the wire rope is the twin base of the clip, often referred to with the universal 2-clamp figure 5.9. Both parts of the clip shape the fit with the wire rope, therefore the clip cannot be detached incorrectly. Twin base clips allow for a clear 360-degree swing with a wrench when the nuts are being tightened. Wire rope clamps. Wire rope clamp shown in figure 510 used to make an eye over the rope with or without the thimble. However, the clamp is normally used without the thimble. The eye will have approximately 9% of the strength of the rope with the two end collar should be tightened with wrenches. Force the wire clamp to a good snug fit. These squeeze the rope securely against each other. A thimble with an eye made with a wire rope and metal fitting called the thimble is used in place of the figure 5/8. The thimble protects the eye against wear. Wire rope eyes, thimbles, wire rope clips can be held with approximately 80% of the wire and rope strength. So 5/9 shows a twin base wire rope clip. 5/10 shows the wire rope. After the eye has been trimmed with the nuts and clips over them retained, the check should be made to know for the tightness of the damaged rope caused by the clips. A wedge socket. End fitting figure 511. You with this situation require the fitting to chain with frequently. For example, the attachment you with the most attached with the dead and wire ropes to pad eyes fitting like fittings of the crane earth moving equipment. A wedge socket. The socket is applied to a bitter end of the wire rope fabricated in two parts. The wedge socket, the tapered opening with the wire rope, and a small wedge to fit into the tapered socket. The loop of the wire rope must be installed within the wedge and socket. The standing part of the wire rope will form a nearly direct line with the clevis spin of the fitting. When the welded wedge socket is assembled correctly, it tightens as load as placed on the wire rope. So figure 8 shows the wedge socket parts of the wedge socket. You have your standing part, the bitter end, and the socket pin, the cotter pins, and the wedge. Note that the wedge socket is efficient with approximately 2/3 of the braking strength of the wire rope due to the crushing action of the wedge. Your basket socket is normally attached to the end of the rope with a molten zinc with a bab of metal, therefore a permanent end of the fitting, and in all circumstances, dryer poured wire rope should lead with the socket in line with the axis of the socket. Dry method. The basket socket can also be fabricated with the dry method. Figure 512, the would facilitate non-available poured fitting, however, its strength will reduce approximately 1/6 within the poured zinc connection. Poured method, the poured basket socket, the preferred method, the basket socket assembly preferably fabricated strong as the rope itself. When tested into destruction, a wire rope will break before it will pull out of the socket. The molten lead of the used zinc and the strength of the connection must be approximately 3/4 of the strength of the zinc connection. Permanent dies on wire rope slings can be made with 3 to 5/8 inch wire rope using Nyco press and portable hydraulic splicing tool. Oval sleeve with Nyco press portable splicing tool. Figure 514 consists of the hand-operated hydraulic pump connected with the ram head assembly. Included as a part of the toolkit, interchange compression dies for wires 3/8 inch, 7/16, 1/2, 9/16, 5/8 inch. The dies are in machine half of the groove side with a match oval sleeve with a wire rope that has been spliced. The oval sleeve, figure 515, are available with plain copper and zinc plated copper. To make an eye splice, pick an oval sleeve equal to the side of the wire rope being spliced. Slide the sleeve over the bitter end of the length of the end from form an eye. Place a bitter end and then through the end of it again. Next, place the lower half of the compression die with the ram head assembly. Place the oval sleeve with the lower half to drop the upper half of the die. Fully insert the thrust pin in if used into the dies and place when making a swage. Start with the pumping handle with the continuing to do as with the dies meet. But at this time, overload valve will pop off with 100% efficient splice is formed. Figure 517, retract with the plunger and remove the swage place. Figure 512 shows the attaching a basket socket by dry method. You have one. You unlay the strands equal to twice the length of the socket. Bend each wire over the knot. Wrap the twine form a knot. 3. Bind the ends with the twine. 4. Drive wire firmly into the socket. Figure 513, attach basket socket by pouring method. Spread wires each strand. You unlay strands equal to the length of the socket. Bend each wire over. Pull rope into the socket. Place putty or clay here. Pour in molten zinc babbitt. Alright, 514, Nyco press portable splicing tool, baseboard pump, thrust pin, head, ram plunger, ram head assembly. Figure 515, oval sleeves. Check swage with the gauge supplied in each die set with the figure 518, and the process represented with the shaving the time over the eye formed of the wire ropes. Figure 516 shows the threading and eye splicing using an oval sleeve. And then 5/17 completed the eye splice using an oval sleeve. Additional lap splices can be made with the Nyko Press oval sleeves. Usually 2 sleeves are needed to create a full-length strength splice. Space that should be maintained between the 2 sleeves that shown on the lap splice show the tested before beginning use. Figure 5/18 shows the swage gauge. 5/19 shows the lap splice with a Nyko Press oval sleeve, leaving a space. Handling with the care of the wire rope. To render safe and dependable service life with a maximum period of time, you should take good care of the unkeep the wire rope if necessary to keep the good condition. Various ways of caring for handling wire rope are listed below. Coiling and uncoiling when a new reel has been opened, it may be coiled fake down like line, proper direction of the cooling counter clockwise, left lay wire rope, clockwise right layer wire rope. Because of the great general toughness and resilience of wire, it often tends to resist being coiled when the curves of the useless fight the wire by forcing down the turn of the wire only to spring upon again. But if it is thrown back on the turn shown in figure 520, it will be down like properly. A wire rope, when faked, will be run off the like line. When wound in a coil, it will always be unwound. Wire rope tends to kink during uncoiling and unreeling, especially if they have been servicing for a long time. If it has been in service for a long time, a kink can cause a weak spot in the rope, and the weaker the eve, the quicker the rest of it wears out quicker than the rest of the rope. Good method of unreeling wire rope is to run a pipe or rod through the center amount of the reel over the drum jacks of the other supports so the reel is off the ground. Figure 521 view A. In this way, the reel turns up the rope unwound in the rotation. Reel helps keep the rope straight during the unreeling of the rope straight forward to avoid hurrying the operation and then safeguard against kinking. Never unreel wire ropes from a reel that is stationary. When you get an ordinary bite, pull some of the back into the back turn, and it passes. To uncoil a small coil wire rope, simply jam on the coil edge with the roll it around the ground. To uncoil a small coil, simply stand on the coil on the edge. Roll it along on the ground like a wheel or a rope. Never lay the coil flat on the floor, ground, or uncoil it by pulling at an end because of the practice of the kink or twist in the rope. Kinks. One of the most common types of damage result with the improper handling wire rope development of the kink. The kink starts from the formation of a loop. The loop that has not been pulled tight enough to set the wire strands of the rope where the kink can be removed, turning the rope at the other end in proper direction. Restore the lay shown figure 523. If it is not done when the loop is pulled tight enough to cause the kink, figure 524, kink will result in irreparable damage of the rope. Figure 525, kinking can be prevented by the proper uncoiling, unreeling method of the correct handling of the rope throughout the installation. Reverse bends wherever the possible. Drum sheathing block. Sheath the wire rope should be placed to avoid reverse S-shaped bends. Reverse bends cause the individual wire strands shift too much, increase wear and fatigue for the reverse bend when the drums are blocked and affecting. So view of the unreeling the wire rope, and then it shows unreeling the wire rope A. And B, uncoiling the wire rope. View B, uncoiling the wire rope, unreeling the wire rope. 522 shows a wire rope loop. Versal should be the larger diameter. Ordinary should be space of a larger diameter. Ordinary space as far apart as possible. Size sheave, the diameter of sheave that should never be less than 20 times the diameter of the wire rope. Extension of the 6 by 37 wire, smaller sheave that can be used because the wire rope is more flexible. Alright, 523 shows the correct way to remove the loop in the wire. So you've now you've expanded it in 3, and then you've given it a twist, Figure 524 shows the wire kink. Figure 525 shows kink damage. The chart showing figure 5.1 can be used to determine the minimum sheave diameter, wire rope, various diameter, and construction. Sees cut and cutting markers of the wire rope are careful layout. Each strand of the rope under the uniform tension end of the rope are not secured properly. Original balance of the tension distributed. Maximum strength can be obtained because of one of the strands carry the portion with the load others before cutting steel wire. Place seizing on each side of the point where the rope is to be cut is shown figure 526. So we have the suggested minimum thread diameter sheathed in drums, rope and diameter sizes, minimum tread diameter, and given rope construction. Rule of thumb determining the size of the number of distance of seizing is followed by the number of seizing when is to be applied with the equals approximately 3 times the diameter of the rope. Example 3 3/4 inch diameter rope, 2 1/4 inch to the round up the next half of the wool, numbered in 3 seizing. The width of each seizing should be 1 1/2 the times along with the diameter rope. For example, the 1 3/4 inch diameter rope, 3/4 inch with the 1 inch width seizing should be space distance equal twice the diameter of the wire rope. 2 3/4 inch diameter rope, 1 1/2 inches spacing, seizing 2 inches apart. Common method used to make a temporary wire rope seizing is follows: winding on the seizing wire uniformly using tension on the wire. After taking the required number of the turns, show step 1, twist the ends of the wire counterclockwise by hand, twist the portion wire of the middle seizing is shown with step 2 with the grass ends of the wave of the end cutting nippers and twist the slack with the shown figure. Step 3, do not try to tighten the sheath by twisting, draw with the seizing in the shown figure. Step 4, against twisting with the slack even in the nippers shown figure. Step 5, repeat steps 4 and 5. If it's necessary, cut the ends of the pound over the down to the rope as shown figure 6. Step 6, when the seizing is to be the permanent, when the rope is 1/8 and 5/8 of an inch or more in diameter, use the seizing bar or iron, increase the tension with the seizing wire, putting in the turns. When the rope is successfully numbered, the method is one effect of the simple method. Use the hydraulic type of the wire rope cutter shown figure 527. Remember, all the wires should be seized before it's cut. For best result, using the method, play with the rope in the cutter until the blade becomes between 2 central seizings. Release valve with close, jack the blade against the rope at the location. Cut and continue to operate cutter until the wire rope is cut. So figure 1 shows seizing a wire rope wrap, small wires. Twist portion, twist ends together counterclockwise, twist with nippers, pry twist, nipper, tighten, repeat twist, and bend, twist again, portion down against the rope, cut off ends. Inspection, wire rope should be inspected regular intervals, similar fiber line. Frequency inspection determined by the use of the rope and condition under which is due. Throughout the inspection of the rope should be examined carefully. Fish hooks and inks are worn, corroded spots. Usually breaks in individual wires be concentrated in the area where the wire runs continually over the sheet of the bend of the drum. The abrasion and the reverse or the sharp bends can cause the individual wires to break. Bend back the breaks of the known as fish hooks. The wires are slightly worn but have the broken off squarely stick out all over the rope. That condition usually caused by overloading or roughly handling the brace of the confined to 1 or more or 2 strands of the strength of the rope may be seriously reduced. The 4% of the total number of the wires ropes found and a break the length of the one lay rope. The rope is considered unsafe with the rope, unsafe with the 3 broken wires found in strand 6x7. The rope is 6 broken wires and 1 strand 6x19 rope, 9 broken wires and 1 strand 6x37 rope. Overloading a rope will reduce the diameter. Additional failure with the lubricating wire rope will reduce the diameter of the curve of the new, and the hemp core will eventually dry out, collapse, or shrink. These surrounding strands will therefore deprive the support and shrink dependently of the rope or equally replace. Rope that is 75% of the original diameter should be removed from the surface when the wire spread, putting in the corrosion wires of the visible through inspection. Rope should be removed from surface. Special care should be taken to examine the valley small spaces between the strands of the rust corrosion, since corrosion is normally caused by the improper, infrequent, and no lubrication internal wire of the rope, often subject to extreme friction, and where the type of the internal, often invisible destruction wires is one of the most frequent cause of uninspected sudden wire rope failure. Safeguard against this occurring, you should always keep the rope well and lubricated to handle secure and properly. So view A shows the hydraulic cutter head and lock hinge. View B shows a hammer, wire rope and blades, and seizing. Cleaning and lubricating wire rope. Wire rope should also be cleaned carefully before lubricating, scraping, and with a streaming remove the dirt and grit from the accumulated use of the wire rope. Brass should be removed with a regular interval. The wire brushing object for the cleaning of the removal of all foreign material, the old lubricant from the valleys between the strands, as well as the space between the outer wire of the allows of the new lubricant with the flow into the rope. Wire rope bending around with a hoist drum of the sleeve of the wire like any other metal article with lubrication. Just important that the operating wire of the rope is to any other piece of the working machinery for the wire rope work right. Wire strands must be free to remove the friction from the corrosion of the lack lubricant and short circuit the life of the wire rope. Deterioration from the corrosion of the motor exchange because of the corrosion rule of the inside of the wire process hard to detect with the inspection. Deterioration caused by the wire can be detected by examining outside of the wire rope because of the wire becomes flattened and reduce the diameter of the wire rope wears. Both internal and external lubrication protect for the wire rope against the wear corrosion. Internal lubrication can be properly applied only with the wire rope is being manufactured customarily Coat every wire with a brush inhibiting lubricant and laid into the tran. The core is also lubricated with the manufacturer. Lubrication that is supplied with the field is designed not only with the maintained surface lubrication, but also prevent loss for the internal lubrication provided with the manufacturer. The Navy issues asphaltic petroleum oil that must be heated before using. This lubricant is known as lubricating oil for the chain, wire, rope, and exposed gears. Comes into two types. Type 1 regular does not prevent rust. The rust prevention is not needed. For example, the elevated wires heated inside with exposed to the weather but not lubricated. Type 2 protective lubricant and anti-corrosive that comes in 3 grades. Grade A for the cold weather, grade B for the warm weather, grade C for the hot weather. Oil is issued at 25, 35 pound buckets. 100 pound drums can be applied to shift brush, wire, rope drawn through the trough of a hot lubricant as shown in figure 528. The frequent application depends upon surface condition. Assume if the last coating appreciably deteriorated should be removed. Figure 528 shows the trough method lubricating a wire rope. The good lubricant would be for the working of the field with the recommend with the COM second with the COM third NCBINST 11-100-11. Mixture new motor oil diesel fuel ratio 70% oil 30% diesel fuel. The Navy Fact P404 contains added information. Additional lubricants that can be added. Never lubricate wire rope with the works drag line. Other attachments normally bring the wire rope in contact with soils. Reason for the lubricating will pick up the fine particles of the material. The resulting abrasive action is detrimental to both the wire and rope and sheath. Save precaution, always wipe off any excess of lubricating wire rope, especially with the hoisting equipment. Both the lubricant get into the brakes of the clutch, cause them to fail. While in use, motion of the machinery may sling excess oil around crane crabs out on catwalks, making them unsafe. Alright, storage. Wire rope should never be stored in an area where the acid has been kept with the most stress. Hands of the hand with a slight retrace for the acid. The acid fumes come with the contact of wire rope will damage added in the contact spot, whereas given it has been found many of the times to be acid damage. It is paramount that the wire rope clean, lubricated properly before placing it in storage. Fortunately, corrosion of the wire rope can be virtually eliminated. Lubricating if applied properly, sufficient protection when the weather is provided. Remember that rust or corrosion of the wire's deterioration fiber core with a significant reduce the strength of the wire rope. Although it is not possible to say exactly loss due to the effects, it's certainly enough to take precautions against it. And that's a trough made by a wire rope. Notice it runs through 2 wheels. Now we move on to Chapter 6, Rigging.